Masuri here. So last session we actually introduced the OpenGL and talked about how the graphics and shapes are rendered and what do we need actually for a sophisticated graphical user interface. And we had some experiment with this lightweight OpenGL library, which is on top of the OpenGL C library. And we spoke about that actually we cannot get more lower level than this. This is the most and the lowest level that we can get near to the graphical processing unit, GPU. So so if you remember, we run this sample application and we draw a line from the center of the page to this, from the center of this canvas to the corner, to the top corner. And actually this is the sample code that we just copied and pasted from the LWJGL website. And there are a lot of things going on here about windowing, creating a window and setting the size of the window, positioning the window and all that. And we have promised to, actually we will get into details, not very detailed, but we will try to explain the bits that are important to us. So, sorry. This is the main loop here. And this is the part that we draw that line. And I want to first talk a little bit about this part here. So let me just, after initializing the context, graphic context, all the games and GUI, graphical user interfaces, all the applications that have some sort of GUI, all of them have this while infinite loop inside them. So they all have this while loop inside them that loops until the user closes the application. So when you, for example, click on some application here, which is a desktop application, or when you tap on one of your applications on your mobile, first a window is appeared on top of other windows. So a window is created for your application, and then that framework, the framework that the application has been written on, gets the canvas, asks for a canvas from the window. So each window has a canvas that we can draw. And pretty much, if you just, for example, take a look at this IntelliJ IDEA itself, which is a desktop application, this is a graphical user interface, and all you see here is texts and shapes and vector images and all just shapes and text and SVGs. Just pretty much these are the primitive things that are used for composing a graphical user interface. So as we said before, the only thing that we need to have a graphical user interface is a window which has a canvas that we can draw on. And also this window should have touch and click capabilities, touch or click capabilities. So we've asked from the Java wrapper on top of the OpenGL library for opening a window, and then inside this while true loop, first we clear the screen. First we, at each frame, so these are the frames that inside these while true. So basically it is saying that while the window is not closed and is open, so this is the next frame that we are going to draw. Clear the canvas, then draw this stuff, draw everything, and then draw everything on the window, on the canvas of the window, and then swap buffers means show the content inside the window. And yeah, and this last line here is saying that then it waits for the touch and click and key events on the window, on top of the window. So if a user, for example, clicks on a window, so this while loop will loop forever, and it will forever it will clear the screen, draw the stuff, and show the stuff, and then check for the events. And again, at the next loop, it will again clear everything on the screen, draw stuff, draw the UI, and then swap and show the stuff, and then get the events. So we just copied and pasted. If you remember last session, we just copied and pasted these lines from Stack Overflow, which it wasn't about the Java, it was about C, I think C++ code. And you can see that C codes are also usable, you know. We can use them here because this LWJGL library is just a wrapper library on top of the OpenGL, and it has not changed the function names and anything. Everything is just the same. It just relays, you know, it was just calls these functions on your behalf, calls these C++ functions, the same functions on your behalf on the lower levels. So by this we draw a line, and we want to now experiment and test other shapes and stuff and see what we can do. So in order to command the GPU that we want to draw something, the OpenGL has a bunch of functions actually to specify the beginning and endings of that shape. So for example, if you want to draw something, first you have to say GL begin. You have to call this function GL begin, and you have to say what you are going to draw, and then you give the points on your shape that you are going to draw, and then you issue a GL end, meaning that I'm done drawing this bit of shape or line or anything, and it will draw that based on the color. So you can issue a GL color function call and give your specific color, and the next GL begin and end will draw the stuff based on the given color, you know. So let's actually do other stuff. This GL lines here means that between the GL begin and GL end, all the points that I'm going to give you, all the coordinates and points on the screen that I'm going to give you are points on a line, for example, or are points on a polygon, surrounding a polygon. Or yeah, for example, this lines here means if we, for example, change it to line strip, I think, line strip, and we, for example, give other coordinates here. We are telling from the center of the page to the top corner. Let's say, let's give other one here, and let's see now what will happen. Okay, you can see that the points that we are giving are forming a line strip. So each two consecutive points are indicating the beginning and end of the next line. For example, the first two indicates this line, then the next two, you know, beginning from the end of the last line, indicates the next line. And so let's actually extract some methods and functions, because this is ugly here. Let's say we have a function named draw content, and let's cut this, and here we say we are going to draw our content. before swapping the buffer. Okay. Let's get rid of these comments as well. So inside the draw comment, let's have another function named fun draw line. And for drawing a line, actually we want to have our own library on top of the OpenGL, because for drawing a simple line, we don't want to issue those ugly functions, GL vertex 2f, GL, I don't know, those functions. We want to give a declarative command, and we don't want to be overwhelmed with the complexity and the terminology of the lower level libraries. So for drawing a line, let's say we need 2 points, and let's define this point as a class here. Let's say we have a class named point, and this point class has x and y, and let's say for drawing a line, we can ask for 2 points. For example, we can say P1 as point and P2 as point, and here I paste those stuff here, and I don't want to actually see these lines. You know, I don't want to be in touch, you know, and know that anything is what is going on beneath, you know. I don't want to know that I have to issue GL vertex 2f and GL begin and GL end in that order. Okay, so let's get rid of this one, because draw line, let's have it here, actually setting the color, and we will refactor this later. So for drawing a line between 2 points, we say, okay, GL, please start drawing lines. Please start, how can I put it? Let me just, please start interpreting. So we are talking to the OpenGL, and the OpenGL will talk to the GPU. We are telling, okay, OpenGL, please interpret the next positions and coordinates that I'm going to give you as points and positions on lines, on a strip of lines. So we have to convert this P1 and P2, and also we don't want to be actually, you know, working with this 0, 0, and you know, the range of the coordinates that we can give to the GL vertex 2f is from -1 to +1, and we don't want to work with those axis ranges. We want to work with the width and height, actually. So let's say if here we issue a draw line, and when we give the points, for example, we say from 10 and 10 to, for example, 200 and 200. You can see that we are not telling from, for example, -1 to +1, because we want to think in the space of the width and height of the window and the canvas. So we have to convert it to something that GL vertex understands, which is between -1 and +1. So let's write these 2 functions. I'm gonna make them private. Private 1, let's forget about this private 1. Let's call these functions actually convert point to, let's say, OpenGL. Convert point x to OpenGL x. So we want to convert the x coordinate, you know, to the thing, to some value that the OpenGL understands, and that is between -1 and +1. So x int. So if we actually divide the x to the width of the screen, width of the canvas, we will have the position as some kind of between 0 and 1. Now, if we multiply it by 2 and give a -1, it will give us the exact number that we want. Actually, it will convert the width and height system in a space to this -1 and +1 space. So if we say 2 multiplied by x divided by window width -1, and notice that we don't have the window width yet. We don't have it yet. And we, in the sample code, they have given this width and height here. So let's store them, both of them here. Private val, make them var, window width as integer. For example, give it 300, and window height as 300 as well. And instead of hard coding, let's give the value here, window width and window height. Okay, now we have the window width, but let's make this value a floating point number, because if we divide it, it might, you know, we are dividing two integer numbers, it will truncate, and we don't want that. Actually, also we need another function here for converting the y and y, and that's the same. We divide it with the window height, and here, let's get rid of these. We can say, okay, GL vertex to F, convert point x to OpenGL x, and we give the x position, and also convert the y of the P1. Let's make it val. Okay, and the next vertex, the next coordinate will be the P2, and let's run it and see what will happen. We don't see anything on the screen. We don't see anything. So the x and the y, P2, P1, when converting, we have this 2 multiplied by x window width and y window height, and these are the strip, and the color is green. Everything is fine, but I don't know why it's not showing anything. So for example, let's let me see. Window width is 300, the window height is 300, and we are multiplying them. Okay, let's see. Y and x. The y will be it's not drawing the line in it. I don't know why. Let's change it to GL lines. See if it will work or not. No, it's not working. Maybe it's because of here. Let's change it to float to see. To float. But I don't think. Yeah. So this part inside the parentheses, actually we were dividing two integers, and that was resulting to the 0, and it was every time 2 multiplied by 0. And by changing x and y to floating number, now the result of the dividing to some integer won't be 0. it won't truncate. So yep, now we have this draw line function that we can use easily without actually noticing that all these complexities are actually involved in the way to draw this line. For example, we can have another function like this one. Let's say font draw line. Let's give a var arg argument points, and so var arg is a actually they can say syntactic sugar around the arrays. So you can give as many as points that you like when you call this draw line. Again, it's the same, but this time we want to iterate over all of the points inside the given points. So for each we want to issue a coordinate in the OpenGL system. So we say it.x and it.y or y. And now if we, for example, give more than 2 points, for example, we say point from 10 to 10 from 200, let's say 150. Let's give another one, for example, point, another point. Let's give 300 and 300, which is the end of the window and canvas. And let's run it. Oh, you can see that it's drawing 2 separate lines. These are not, we actually expect it to be a strip of lines connected to each other, because you can see here that we are telling the OpenGL to interpret the next incoming positions as discrete lines. If you want the OpenGL to draw a strip of lines, we have to tell it to do so. We have to indicate it, actually interpret it as line strip. Now if we run it again, you can see that we have a connected strip of lines actually specified by the given positions points. So this is the first and the simplest draw command. Let's actually write another one which is actually more interesting. So when we want to draw a shape, so the common shapes are the rectangles, circles, triangles, and actually we can categorize them as drawing polygons or drawing paths. We can issue another GL begin command. Let's say we have this draw polygon, and the polygon is indicated by the given points again. So the code is pretty much the same. So if I copy and paste, let me just copy and paste the whole function here, actually, to prove that draw polygon. Sorry. The only thing that differs is that instead of telling the OpenGL to take these points and positions as points on lines and connected in strip lines, we want to tell the OpenGL that interpret these positions on the polygon, on a polygon. So we have to say GL polygon. And also we have to give, I think we have to give the first, because we have to close the polygon, we have to give the first point at the end as well, I think. Let's call the draw polygon instead of drawing a line, and say from 10 to 200 and 200 and 200. Let's come to 300 and 100. So 300 and 100, that will be like this and like this, and let's close it and see what will happen. Okay, you can see that we draw a triangle by actually giving these three, 1, 2, and these 3 points on the screen. So we just you just pretty much get the idea that when you are talking to the GPU, you just describe the content of the next drawing that you are going to issue. You tell it actually, okay, OpenGL, please interpret these positions as points on line, on one line, on a strip of lines, or interpret these positions as the points defining a polygon. So now that we have this draw polygon function, we can define, for example, some common shapes like draw rectangle. Let's say a rectangle. For drawing a rectangle, we need two points. Yeah, the first one is the, for example, let's ask for the left bottom point, and also let's ask for the top right point. So the only thing that we have to do here is issue a draw polygon and give the edges, you know, on the points of the edges on the rectangle. So the first one would be the LB itself, the left bottom. Then we come to we have another point, left bottom, top, left top, yes, will be let's see. So the X will be same as the left bottom X, but the Y will be top right dot Y. Then the other one will be, so we need another point here. So over here we come as far as the top right, the Y, the difference, then we come in this direction, and then we have to, yes, for coming to this direction, we have to give the top right X and top right Y, yeah, then left bottom X and top right Y. Then also again we have to give the last point as well. Okay, so now let's call this draw rectangle. Let's give the left bottom point. For example, let's say our rectangle is, the left bottom point is 10 and 10, and the top right point will be, for example, 100 and 100. And let's run it. Something is not right here, and that's because the left bottom, we come to top, we go to right, then we should come to the 1 2 3 4 5 1 2 3 4 5. So this one here is top right, actually top right, left bottom X, top right Y, then top right, then it has to be top right X and left bottom Y. I think this is okay. Yeah, this is okay. So we have draw rectangle function now, which is on top of the draw polygon, and the draw polygon is actually issuing this GL begin and GL end command with the interpretation of GL polygon. So we are telling, okay, interpret these positions as indicating a polygon, and you can see that let's actually do one more. Let's do one more. Let's say we want to draw a circle. So for drawing a circle, we need a center point, and And also we need radius. So let's get this radius as integer. So you can see that the GPU, you know, does not know anything about the shapes and, you know, does not care about the rectangles, and it only cares about the points that are forming kind of, you know, primary shape. So when you are talking to the graphical user interface, sorry, the GPU, you have to declare and specify your drawing, specify your shape as the points, so as the points surrounding that shape. And you have to tell the OpenGL to interpret those points as lines or as a polygon or as other stuff that we will see. So again, for drawing a circle, there is no function on the GPU. We cannot command the GPU draw a circle. We have to make a circle with these primitive draw functions. So for drawing a circle is basically actually multiple lines, small lines, you know, around the circle shape. So for calculating the points of that line strip or polygon, we have to do some math here. So for if I remember correctly, the x position will be okay. Let's say this is the range. We have the two dots in Kotlin. This is the range operator. We are telling, okay, give me a range between 0 and 3,600, which is 360 degrees multiplied by 10, because and for each, I issue a for each here. I want to produce points on a circle, actually in a circle, and I want to tell the OpenGL to interpret those points and connect those points and form a polygon or a line strip. So we can, I want to actually, the more points we produce on the imaginary circle, it will be more smooth and it will be more circle-like. So I think 3,600 points is enough. Let's say point, and here I have to calculate the x and y of this point. So these points on the circle, we just do a math here with sinus and trigonometry mathematics here. The x is radius multiplied by, I think, sinus. Yes. And then we say math dot 2 radians, because we are giving degrees here. These are degrees here. And let's see, this is 2 double. Let's convert it to double. We have to actually divide this to 10, I think. Yes. And also let's calculate the y here, and this will be the sinus. Sin. Yep. And let's give this x and y, and we have to convert it to integer here because point asks for integer x and y's. Okay, now we have to gather and actually accumulate all these points, calculated points, and the better way is to use map function. We are mapping this range of numbers to points, so it will be a list of points. So we will have points list, and we have to, and now that we have points list, the only thing that we need to do is to call draw polygon and pass this points list. And let's make it a list. Sorry, draw polygon is Okay, using this var arg, let's copy and paste it and have points, another function with the signature. Points as list of points. And yes, now we can call it and pass our points. And we have to actually take into account the center. So the center, we can say center.x plus and also center.y plus. Let's put it to test. Let's say draw a circle. So let's give the middle of the window, which is 150, as the center of the circle, and for example radius as 50. Now let's run it to see what will happen, and we have a circle. So this circle, you can see actually the jagged points and lines here. These are lines that are, because there are a lot of 1,800 lines forming this polygon shape. So it is, our brain thinks that it's a circle, but this is not a circle. Okay, let's talk about this last thing, which is actually, you can see if you pass it to draw lines, no, this one. So you can see that the polygons are all filled with the color, with the given color. We want to be able to make it actually empty, stroke sometimes. So you can do that. By filling here, like that we've here specified the color. We can specify the fill mode, and that is a GL polygon mode, and we give this GL front and back. And I'm not expert in the OpenGL, I've just searched for these things actually. And if we say GL line, we are telling the OpenGL that interpret the points as lines and don't fill the shape. And now let's run it to see what will happen. You can see that the shapes here are just the polygons are not filled with the given color. And if we again make it fill, GL fill, it will fill that polygon for us. Okay. Also, if we make it line, we can specify the line width, the scroll width, and that is with the GL stroke line width, I think. Line width, so yes, line width. For example, let's make it 5F. Yes, let's run it. Yeah, you can see the lines are, the thickness of the lines are 5 pixels, I think. So yeah, so let's just, this is enough for this session. Let's just summarize it. So in order to be able to have a graphical user interface, we need a canvas. We need a window and which understands clicks and touch, maybe finger touches, and also we need the canvas inside it so we can draw our stuff. And we only just, even those fancy UIs that you see are composed of basic draw lines, draw rectangles, draw text. We will see the draw text, we will talk about the draw text the next session. Draw image. So the image is just like loading the data of some image on your actually computer, and then drawing the actually the image is composed of points. Each point has its own color and it forms a picture, it forms an image for us. So yeah, the next sessions actually we will continue and we will have more functions like these, and then we will try to write a basic graphical user interface for our application for showing the products. So stay tuned and thank you. Bye.